and welcome to Faster Scan to PDMS Workflows, new tools and technologies for modeling and importing as-built pipes and components into PDMS. My name is Chris Scotton. I'm the President and CEO of ClearEdge 3D. And we've got just a great session for you today. It's kind of a mix of the old guard in John Hill, one of the most experienced PDMS guys, experience and perspective to the session. And we also have Kevin Williams, who is the founder of ClearEdge 3D, and he's the company's resident math genius. So we've got two gurus and a genius, and I have no idea what I'm doing here. I think I will try to keep the session going and the discussion lively. Without further ado, let's go on to the next slide, please. So the agenda for today, I'll just start it off with some goals and some context. And then hand it off to Matthew Bird, who is the 3D manager at DeWalt. He's got a really interesting case study of an oil processing facility that was done on a really tight deadline with an intelligent PDMS model as the deliverable. And then we'll hand it off to John Hill, who again is with AMEC and has really devised this quite amazing workflow to get third-party intelligent models, in this case Edgewise, into PDMS. And then we'll hand it off to Kevin Williams to talk about some of the new features and functionality in Edgewise Plant and the company's newest product in Edgewise Structure coming out shortly. And then we'll have a Q&A. Where you can ask the experts as many questions as you need, and hopefully we'll have time to answer. If we could go to the next slide, please. All right. So just a couple housekeeping things. Everyone is muted, obviously, except the presenters. And if the presenters could please mute yourselves now if you're not speaking, that would be great. That'll keep any background noise away. Thank you very much. And feel free to ask questions during the session, either in the chat window or the question window. And we'll take some Q&A after each presenter. Most of the Q&A we'll have at the very end. And again, we'll get as many questions as we possibly can. We've got about 480 people registered for the session, so it's going to be full. And last time we did this, we had about 120 questions, and we didn't get to everyone, so I apologize. The webinar will be recorded, and so everyone will receive a link to view a download or to actually download it if you need to. And Kevin Corbley, who is in Europe right now with his family, he would be upset if I didn't mention Workflow 4.0. If you're not a current subscriber to Workflow 4.0, please do. It's a great newsletter. We're the lead sponsor of it, and Kevin just does a great job of pulling together case studies and so forth. So go to the next slide, please. Next slide. So next slide, please. Thank you. All right, there we go. Okay, so if the presenters could unmute themselves and just introduce yourselves briefly. First is Matthew Bird. He's the 3D manager at DeWalt Corporation. Matthew, how are you?
Good. How are you doing?
All right, great. And John Hill is 3D Design Systems Manager with AMEC. AMEC's one of the largest design build firms, engineering firms on the planet, with about 28,000 employees. John, how are you?
I'm doing fine.
All right, great. And then lastly is Kevin Williams, who's Chief Scientist and Math Genius at ClearEdge 3D and the founder as well. Hey, Kevin.
Hey, Chris.
All right. Great. So let's dive right in. If you go to the next slide, please. So a couple just quick goals for today's session. We really want to jump into DeWalt Corporation's workflow, because they really have created an incredibly efficient and effective workflow, and we're going to do that in the form of a case study that Matthew's going to lead us through of an oil processing facility that they did recently that is quite unique, and the turnaround time was very, very tight. And one of the interesting things about that session is that they used targetless registration in addition to targets, and so Matthew is going to kind of compare and contrast, the pros and cons of targetless registration and the use of targets. So there are definitely pros and cons for those. John is going to show us a new tool for bringing intelligent models, in this case edgewise, directly into PDMS, and thereby eliminating the need to remodel. And then Kevin's going to talk about some of the new features in edgewise plant and edgewise structure. So we can go to the next slide quickly, please. And again, presenters, if you're not speaking, please mute your microphones. So just to give everything a bit of context here, this is kind of an old story in the service provider marketplace. Owner-operators and EPCs, they want three things from their projects. They want it fast, accurate, and they want it at low cost. And service providers typically can deliver 2 out of the 3, which really does put a tremendous amount of pressure on the end relationship and the deliverable. One of the challenges with a PDMS deliverable is, it's a great platform. It's a very, very powerful and top market share, but the support for third-party packages is somewhat limited. The native tools that they have within LFM are quite good. Very, very solid, robust tools, but they are manual. So, there's not a lot of automation there. And the further challenge, I think, is that most service providers can't afford or don't have a PDMS license, so they can't do the modeling in PDMS. They typically will have to model it elsewhere, and then the EPC or owner-operator will bring it into PDMS and then have to remodel it. And again, so that's a really inefficient workflow. And the workflow that Matthew Bird is going to talk about really kind of dramatically reduces that whole amount of time. So let's go to the next slide, and I will hand it over to Matthew. Matthew, you're with us.
All right. Yes. Good morning. Thank you.
All right. Take it away, Matt.
All right. Thanks for being here. We're going to be reviewing a case study of a recent oil processing facility that we did scanning and modeling on. So we'll go to this next page. First, a little background on DeWalt Corporation. Located in Bakersfield, California, just about an hour north of Los Angeles. DeWalt was established in 1965, civil engineering and land surveying firm, working a lot in residential, oil field, and just multiple services and industries. So this project that we recently did was a large oil treatment facility. The entire area was about 600 by 600 feet. This specific project was due to changing how this facility works. So there would be a little bit of changing everything inside of the plant. They would be removing tanks, rerouting pipelines, adding new pipelines, and they still want to utilize some of the existing equipment, existing pipe supports, therefore leading to scanning and modeling and using an as-built model to help design with what's already at the site. As you can see some pictures on the right, there's some of the pipes and pipe racks. You'll see a little bit more on these next slides. So our scope for this project, as you can see in the right in the blue highlight, this is the entire 600 by 600 foot area that we were requested to scan. And inside that, there's the entire facility, as well as outside areas of pumps and pipes. And so in the middle there, it's quite detailed. So first we were to scan that, provide an ortho photo of the site, which we used from the point cloud, and we geo-referenced that onto the coordinate system that they're using. Next, we would deliver a complete 3D colorized point cloud, which we found is very useful inside of programs like Navisworks for site visualization, just using to review a project with a clean point cloud. It's very useful. We would then do the as-built 3D model of a requested area. We didn't model the entire facility. They have it split up in different sections and what they would be utilizing currently. So you can see on the bottom right, highlighted in red, this was the area that we would be doing our modeling to begin. Once the modeling was done, we were to deliver it onto a requested coordinate system and be able to import that into PDMS and AutoCAD formats. So here were a couple unique challenges. As you can see on the right, some of those areas inside of the red where we were to model, from the top aerial photo, it doesn't look quite all that detailed, but once you get inside the site, you can see here in these pictures, there's a lot going on. There's a lot of pipe, there's a lot of supports, valves, flanges, just a lot of stuff that you don't want to miss. So we needed a quick turnaround time. Our goal was to do 3 weeks from start to finish. And another unique challenge in a project, a large project, is managing your data. We ended up with nearly 500 gigabytes of data. As you know, with scanning, scan files, as you bring them into multiple softwares, they can create their own specific file types inside different softwares, just compounding and compiling new files and new sizes. And of course, because of the amount of modeling that we had to turn around, that was another challenge. Estimated over 3,500 feet of pipelines, and inside of all that there's valves, flanges, pipe supports, concrete foundations, vessels, tanks, equipment, and a lot of steel. So we'll move on to the next page here and go over a little bit of our workflow. The image on the right is kind of a way that we use to do planning and mapping on how we're going to best capture a site when we get in. So the scanner we used is a Faro Focus 3D. We're very happy with this hardware and equipment. We start by using the aerial photo and map out a per day scan area we want to try to capture. So obviously we had a priority area being what we needed to model, and we made sure we covered that first. Just kind of as a best practice, once you get in the field, we would choose where we want to start and get that first scan going as quickly as possible. During the time of that first scan setup scanning, you'll have, depending on your quality and resolution, 3 to 10 minutes of a window that you can continue mapping out your locations for the next scan setups while that first one is going. And this just kind of helps you maximize your scans. So as the scanner is going, we'll walk through the site and map out the scan locations and the best route to make sure we capture all the data that's needed. As you saw in those previous pictures, there's a lot of things to capture, and if you don't have the correct and enough setups, you may miss some critical data. Of course, we would complete as many scans per day as possible while staying in the approved amount of time. And at the end of each day, review the data captured and kind of set up the plan for the following day. So we know where we scanned, where we ended, where we started, what was captured, and what might have been missed. So that just helps make everything go efficiently. Oh, skipped one here. Here we go. Our field crew is normally 1 to 2 people. The tasks on the field side are laser scanner operation, just moving the scanner, going to the setups, starting it. If you're using targets, making sure you have your targets set up, moving those in between setups. Walking ahead with, if you're in a field and dirt, we'll sometimes use paint or put something on the ground and plan our scan setups beforehand. We'll also take photos of whatever it is that we're going to be scanning and modeling. That way, if something is blurred in data at all or something might get missed, we can go through photos and see some detailed pictures. And those are just ways to make sure that we capture all data that's needed. Planning your route ahead of time is a great time savings and a good way to make sure you don't miss anything. So once we're done with the field portion and we get all of our scan setups, on this specific project we utilized Autodesk Recap Pro, which is a new software for registering scans targetlessly. And we also did use Ferrocene a little bit. We kind of did a combination here. Autodesk Recap Pro actually was released and came out the week that we were using it in this project. We were one of the first people to actually get it and utilize it as the released version. We registered our scans, indexed them into the Autodesk Recap project format, and from Autodesk Recap you can export it to multiple file types, and from there we can move it into the preferred modeling software. As you can see here, this picture is actually inside Autodesk Recap, and we have it in an elevation view. There's some cool tools inside of there, and this is one of them. So you can set it up and see the ground contouring. You can see where water might gather. Just some cool tools. So some of the experience we had during using Autodesk Recap Pro. It is a new software. There's a lot of interest in it, and this is some of the things we've seen. Some of the pros, obviously in scanning, as you know, targets they do take up some time. If you can go to a site and use no targets, and all you have to worry about is moving your scanner and keep scanning, it's really quick, it's really efficient, it's great. So if that's all there was to it, it'd be great. There are some other things though. Like I said, it does overall faster laser scanning because you don't have to move targets and worry about line of sight and making sure you have enough targets. It does turn your field portion into a one-man job. You won't need two people if all you're doing is moving the scanner. You don't have to move your targets. You just plan your route and scan. It's very, very easy and efficient. And also Autodesk Recap, being an Autodesk product, the file types that it provides, the RCS and RCP, are great for other Autodesk applications such as Navisworks. Some of the cons that we've seen are because the software is brand new, it does have some things that needs to be worked out. We had some stability issues in the beginning. It would crash sometimes randomly, and it wouldn't save our progress, but we were able to work through those things, and I think they've already fixed some of them in some patches and releases, so things are continuing to improve. Another issue with targetless registration is the quality reporting isn't quite as detailed from what we've seen thus far, because it's using cloud to cloud. It has a couple tools to just tell you some percentages of what it's estimating it has the quality is reporting as, but because there's not references for it to actually mathematically give you a report, it's just a little harder. So if you're going to use it, you're going to want to implement some way of doing your own quality reporting, such as setting control points and being able to go into your point cloud and compare those to the coordinates inside the point cloud. Some of the suggestions, if you're interested in using Autodesk Recap Pro, is go ahead and download it and use a past project you've already done before getting into a new project. This was kind of a way we trialed it before we used it. So take your old scans, even if there's targets in it, it doesn't matter. You don't have to take them out or anything. You just bring them into Recap. It has a great simple interface. just register those scans, and you can compare it to the quality and the what you've done on your last project. You can compare those point clouds and see how they work out for you. And then, of course, if you're actually interested in switching your target lists, like I said, on your next project, scan with your targets still, and then bring them and register both ways. Use your current software and recap and kind of compare the time savings in both, as well as the quality and accuracy. So kind of summing up our overall experience with recap, the data looks great. Being able to take that file exported from recap into Navisworks is a beautiful way to just visualize your entire site captured. The registering is very easy. You just go in and click a couple similar locations and it ties it together. So we will definitely be using recap on future projects, yet we're not ready to make the complete switch. We are confident in using it still on next projects. It still seems a little bit lacking in handling large projects, but it can be done. If you want to do it again, you'll want to implement some way of checking the quality by using, survey control or something, just so you have some checks. You don't want to go through it with unknowns, and if you have a client who wants a quality report, you got to have some way of providing that. So we're looking forward to Autodesk continuing to stabilize and just improve it. It is a great software. So next, after doing the scanning, after doing the registering, and having a point cloud ready to use, we move into our 3D modeling. So on this project, we would take and import our registered scans into Edgewise Plant, and Innovex Reality Links is the other software we use. As we know, Edgewise Plant currently is for modeling pipelines and components such as valves, flanges, etc. And as we're going to see later, they're working on steel. As you can see in this image on the right, this is a portion of the model with pipelines and steel, and having that Edgewise steel would be very useful in a project like this with this much steel. So we would use our modeling in Innovex and Edgewise, and we would model everything that was requested in the contract, making sure that that's something you follow. When it comes to a scanning and modeling project, making sure you discuss the level of detail and what all needs to be captured is a huge thing you want to make sure is covered. So in this, we modeled a couple of the tanks, vessels, we did steel structure, pipe supports, we did a ground surface model, pipelines, nozzles, valves, flanges, pretty much everything inside of our specified area. As we're going through the modeling, we would do quality checks and make sure that everything that was requested was modeled. We would go into the software and compare the model to the point cloud and make sure that things were done correctly. Once we were finished, we moved the model onto the coordinate system so that we could export that into AutoCAD and PDMS formats. PDMS, if you are a PDMS user, you know has an issue with very large numbers. So the coordinate system model was actually for AutoCAD, and we kept the PDMS model on and offset so that it didn't have issues with the large numbers. So here are some examples. We're going to review how we utilized Edgewise on this specific project. Here are a couple images showing our point cloud inside Edgewise. As it says in the text here, when I process the scans, that's literally a button you push. You set up some settings, and that's where it creates this point cloud in Edgewise format. It'll extract cylinder shapes, pipelines, and you also have the option to do your ground model from there. Edgewise also has a smart sheet, which is the quality inspection tool. You can easily go through and remove things that it grabbed automatically that maybe were not a pipeline but were cylinder shape, you can go through and delete those, and you can easily go through and check the quality of your pipeline to the point cloud and adjust it if needed. So we'll go to these. We have a couple pages with some bigger images here to review these slides. So here's a portion of the point cloud inside of Edgewise. It does a great job creating its own format, and it looks good. And it's easy to move around inside of. So from that point cloud, this is what it automatically extracted inside of Edgewise. You can see, you know, Edgewise does have a great tool for automatically extracting. There is still a portion where you have to go through manually and do some cleanup, delete some things, but it gives you a great head start being able to model a lot. So here again is the comparison from the point cloud image to what it automatically extracted. So when you're dealing with a lot of pipelines, it's a great tool to give you a head start on your modeling. This next slide here shows some of the pipelines in Edgewise and another tool that Edgewise has of automatically cleaning up and connecting your pipelines. It will add elbows, and inside of Edgewise you can also add T's and reducers, flanges and valves. On this specific project we did not utilize Edgewise to its full capability of doing the flanges and valves. We used it for doing all of the pipelines though, and it definitely reduced our pipe modeling by 60 to 70%. It's definitely a great tool for anyone dealing with pipeline modeling. So our final deliverable for this project was the 3D model, and that was requested to be on the coordinate system. Again, not in PDMS due to the large numbers just having some issues, as you know. As you can see in these images here on the right, you can see that we did some tanks, vessels, the nozzles on the vessels, concrete foundations, steel pipe supports, some equipment, pipe racks, pipelines, flanges, valves, and the ground surface model. So this gave them a great start to come in with accurate data of what is in the field already, what can they do with it, and they can start using this model to design off of. They can run new pipelines on existing pipe supports without hitting things. You know, they know what to move and what to use. We delivered this into PDMS and AutoCAD formats using Edgewise export utility and InnovX reality links. Of course, the portion from Edgewise has a way to bring it through intelligently by actually converting the model into PDMS components, which we'll see from John Hill in his portion of this presentation. We also delivered the orthophoto on the coordinate system, which we actually did that in Faro Scene software. It has a way to take the point cloud and clean it up and give you a top view and make an accurate orthophoto, which we could then bring into AutoCAD and place on the coordinate system and really use it like it's an aerial photo with accurate measurements. So then we also delivered the entire register point cloud, and we also delivered the point cloud in the Navisworks compatible format from the Autodesk Recap Pro. And again, that's a great way to visualize your site and use the point cloud for more than just a modeling tool, but really as a site visualization, walking through it in 3D. It's a great tool. So some of the overall tips and tactics I want to leave you with. You know, some of these may be things you already do, some may be new. I just want to share what we utilize. On any large project, we see that it's critical to visit the site, because if you get sent a paper, which if you've done scanning for quite a while, you'll know you've gotten one of those projects where somebody sends you a piece of paper with some lines on it and says they need a couple things scanned, and then you get to the site and it's, you know, it's an entire couple weeks worth of scanning. So before you do any estimating or proposals or anything official, if it's a large project, you want to visit the site so you can really get a feel for what is the level of detail. How long is it going to take? Secondly, communication and a working relationship with your client is definitely key. Just being open with them, giving them realistic goals and how long is this going to take, what can you actually do, give them some tools to utilize. Third, be very specific in your communication with them and in your contract. When it comes down to the 3D modeling, being very specific to what do you need modeled and what is the level of detail that you need. That can be one of the biggest time differences, is what you're modeling. That's definitely where the time's at. So make sure you're specific with that. Workflow planning. Before you get started on your project, once you have an idea of what it's going to require, what you're going to be doing, make sure you know who's going to be handling what tasks, what software you're going to be using, and definitely just know those answers before you start so that your project can just go smoothly from the beginning. You know who's going in the field to scan and who's going to be processing, who's going to be modeling. On this specific project, we had for most of the project, we had 2 people working on it, sometimes 1 and sometimes 3. So just know how you're going to handle those to make it most efficient and cost savings for both you and the client. Safety, as we know, is a huge one. We work a lot in the oil and gas industry, and they're very big on safety. Make sure your personal safety equipment is up to date. If you're going out to a facility, make sure you ask if there's specific guidelines you need to follow while you're there, any additional requirements, and make sure that all that's covered before the project is supposed to start. Quality QC shots. This is what I was talking about earlier, being a survey company. We use these to ensure awareness of possible registration issues. And as I have placed here, it says place survey control points around and through the site. And we would use the XYZ coordinates from the survey control and compare those to the XYZ information in the point cloud. Especially if you're using targetless registration, you want an additional way to be able to go through and make sure that things are registered correctly. You can do so by making cuts in the point cloud and looking down pipelines. But this is an additional way to really check the entire site, really utilizing some of those survey tools. Seventh here, saving and backing up your work. I would do that on a daily and hourly basis, especially anytime you make a big change. If you're sitting there and you process something, or you do a lot of modeling, just go through and save it often and back it up. Even if you have it saved, get an external hard drive and make a copy of your save. That way, if anything goes wrong, technology is technology. Sometimes it crashes. Sometimes it decides to just do its own thing and have a mind of its own. So make sure you save it, make sure you back it up. So if anything happens, you can grab that backup file and start where you left off. If you are doing a scanning and modeling project, and one of the questions you want to ask is if it needs to be on a coordinate system. And if the answer is yes, then make sure you know how you're going to do that before you get in the project. If it's which software it's going to be inside of. Are you going to do the point cloud and the model, move the point cloud or model afterward? Just know how you're going to do that. I know that's one issue that I've heard people have issues with. So, and if you don't know how you're going to do it, look into it. Find somebody who does it and find out how to do that correctly. Integrate new tools into your workflow that offer time savings and value to both you and your client. This is where we utilized Autodesk Recap and the Edgewise plant software. Autodesk Recap for this specific project allowed us to finish our field portion in a more efficient and quick amount of time. not having to move targets, especially in those really detailed and messy areas where there's a lot of pipe and supports and steel. We didn't have to worry about moving targets around, making sure our line of sight was good. We got to move the scanner right where we needed it so we could see the edges of everything that would need to be modeled, and just move through efficiently. We also could come back and do registering of each day at a time and work on that. It was very useful. And the Edgewise software, like I showed you, the extraction of those pipelines when you're dealing with 3,500 feet of pipelines, having it be able to give you a huge head start and get a lot of that done by itself, and then you go in there and clean up and check the quality and adjust, is just a huge help when you're dealing with a lot of pipe. And my last, but definitely not least, tip for anybody is customer service. Be personable. When you hand over the final deliverable, ask them to review it and give you feedback. And just ask the question, how could we make our next project even more efficient and more customized for you? We've, multiple times we've had people just tell us, different clients, different people just say, you wouldn't believe that we've dealt with people who would never offer to come in and sit down with us and review this or try to do better. They just hand over the product, just offer that customer service. Be personable. People know technology isn't perfect. Sometimes things don't go the way as planned, but communication and a working relationship is definitely key. And that is going to sum up my process overview.
All right, great, Matthew. We've got a ton of questions that have come in, a lot of them about recap. Why don't we? I'll ask a couple now, and then the rest we can take at the end. That sound good?
Sure.
Okay, so the first kind of general question is, how many days were you guys on site for this particular project, and what is a day? Is it 8 hours? Is it 12 hours? Is it 14 hours?
Good question. Well, being that we had, as we showed in what we were going to scan, we had that whole 600 and 600 area, yet we still had a smaller portion which was kind of priority that we were going to model. So our workflow really was to capture the entire priority area first so we could get that modeling going, and then we went back out and finished the scanning. So a total of about 6 or 7 scan days, even with a small break in the middle, was on site. And for us, it was an 8-hour day. And of course, that differs per project and per client, whatever is approved. So we stuck to 8-hour days, and it was about 6 or 7 days total of scanning.
I've got a recap question from Dave. So when scanning target lists, what, in your experience, is an acceptable accuracy for registration percentage between scans?
That is a good question. It's an inside recap. There are a couple, they have a percentage tool. When you're doing the registering, it'll come up and show you what amount of data it could see in both scans, because it looks for certain shapes and certain objects to use, and it's set up so in a way that if it's acceptable, it'll come through green and yellow or red depending on what it overlays. But there aren't any real good quality reporting tools inside. That's why you kind of have to set up your own quality check with survey control or something. So that some of that is still kind of on a per service provider basis on how you can handle that quality of reporting.
Last question for now, and then we'll move on to John Hill. How many physical targets did you actually have with you in the field for this project?
Physical targets. So when we did this project, we actually started out using some targets, and then we switched and finished it just after a day or two with doing target lists. So it really helped afterwards. But we have a total of 10 of our sphere targets for our ferro laser scanner. Yet we also do have printed sticker targets that we use. And those, we just have a mass amount of those to use wherever needed, but we have 10 of our real sphere targets.
All right. Actually, I have a follow-up question, which is kind of interesting. I think I know the answer to it. I'm sure you do. Within RECAP, can you use targets at all for registration, or is it purely targetless?
Good question. It is targetless, but RECAP does have a way similar to other softwares where you can actually go in and add your own. You can go in and click on your own points and make them control points to use from scan to scan to kind of help improve the accuracy, which I think I saw another question which that kind of ties into. It's also the same process you use to get, if you want to move the point cloud in RECAP onto a coordinate system. It has a tool in there to go through and actually select an individual point in there and place a point there. So there are tools inside there to do that.
So you can use targets with RECAP. I was under the impression that it was purely targetless.
It is purely targetless. It doesn't have a way to like other software does. It doesn't automatically find targets and such, but you can place individual points to help if you're having registration issues. It does have some minor other tools, but it's not in a way that other software automatically finds all those targets and uses them. So it's not meant for using targets, no.
Got it. Understand. All right, great. Let's move on to John Hill. Kevin, can you give the controls to John? And what John is going to do is take Matthew's project and live bring it right into PDMS.
Okay,
John, take it away.
Right. Can you see my screen?
We can.
All right, good. Okay, the basic import of the data from ClearEdge 3D is fairly simple. We took a simple approach. I worked with Kevin on what was needed to pull in this information into PDMS in an intelligent manner. The basic little application is a plug-in to PDMS. It's a simple form that allows you to define, what the input's going to be and where you're going to store the information. So for this exercise, we're going to store it in a zone called router site pipes. And the project I'm using is out-of-the-box project, the sample project that AVEVA provides with the software. So just everybody knows there's no smoke and mirrors back here. There is an ASME spec mapping facility and one for DIN specs. Within the data file that comes over from ClearEdge 3D, they can identify pressure classes. And so you need to map a PDMS spec to a pressure class. And in this case, I'm just using 150-pound spec that's an out-of-the-box specification for the 3 pressure classes I have identified here. And this is because if you want to bring it in without having to do a lot of selections during the import process, you would build basically a generic routing spec that contained all of the components required with specific types associated with those components, so that the import would be fairly painless. Now, Matthew had sent me a file of the project, and what we'll do is we'll open that file up. And this is the modeling file that we're going to use. Okay. Now, what's going to happen is since the componentry that's identified in the import file is probably not going to match what's in this spec, because this spec is like if you're using your own production specs. It wouldn't have, you know, all the specific types in there that are basically identified within the 3D model. It will have the generic types but not the specific types. Like for elbows, for instance, we use EL90 as a specific type for a long radius 90-degree elbow, EL45, and so on and so forth. Different types of flanges, whether it's a well neck, slip-on, lap joint, and so on. So once you've identified where you're going to store the information and the file that you're going to process, you just have to hit apply. And you'll notice it pops up because I'm looking at a T that is got a 300 millimeter bore. And so I'm just going to go through and select all the defaults for this, just so we can get this in without having to go through too much trouble. And there's obviously there's quite a few. We're looking at both socket weld and threaded piping here. So we just go through and select these to get the model in. And everybody knows that in PDMS, once you've got, you know, the piping model there, you can go in back and modify it in any shape, form, or fashion that you want to. Even go back and change the specification of specific pipes within the model. Now, I cut this particular file down a little bit because of the number of pipes that were in it, just so that we didn't have to sit here and go through all this. Okay. Now, this is the pipe routing that was processed in the model. And as you can see, you know, there are a few lines that have, you know, dash lines which are at the tail of the pipe or at the head of the pipe and stuff like that. And that is primarily due to the accuracy of the scan and the fact that if you have a elbow like that, which is a socket weld elbow, that if the pipe is deflected or bent or something like that, the elbow can't take up the angle because it's a fixed 90-degree angle. In most cases, like for butt weld piping, these elbows will have a variable angle on them so that it will adjust, you know, to the angle of deflection of the pipe. In PDMS, you cannot bend the pipe or anything like that. You would have to go in, if you want to clean this up, at the end of this socket weld elbow, you could put a zero-length variable angle bend, like we do for slope piping in PDMS when we model it, and have that directed towards the pipe tail and have the implied tube come in at that point. During the processing of all this, there is also a text file that is created that shows basically the errors that are generated during the import of these pipes. And you can go through and it'll tell you that, you know, this elbow can't be directed and so on and so forth. So the standard PDMS errors that are generated. If we look at to show that it is actually a workable 3D model, we can actually go in and ISO the line. You will get your standard MTOs out of it, and obviously you notice that there are angular deflections in these pipes, so it'll also show you all of that. But beyond that, everything comes in as was defined within the scan. It's all positioned based on the scan data. We even have where he had actually modeled some of the valves, the flanges. These valves, you would have to go in and that's standard, what you would call a generic gate valve. More than likely what that was a globe valve, so that you see it doesn't fit between the flanges like it should. So there are a few things that you have to do to go in and really clean this model up. Not that much is required to do that. So if there are any questions, I mean, this is very simple. It's a very simple interface, and one of the things that Matthew alluded to was the file size. The data file size cannot exceed 10,000 lines. So essentially, you would break up your export data into smaller chunks, but you can pull in all of that information into multiple sites, zones within the 3D model. So I think that's about it for me, Chris.
All right, great. I've got a question here from Jose Gaspar Lima. Using the PDMS plugin, says using the PDMS plugin, does the point cloud come in? So does it? I guess another way to ask it is, what sort of point cloud support is native within PDMS, and can you bring the edgewise point cloud into PDMS?
The answer would be yes, you could. They use LFM, and there is a LFM interface, so you use LFM server, and there's LFM interface within the PDMS model itself. We have done several jobs that we use laser scanning on for offshore, and where we use the point cloud within PDMS to be able to identify tie-in points and for demolition and so on and so forth. But in that case, we have to back model all of that because we didn't have an interface or basically a way or a mechanism to pull in a model like with ClearEdge 3D.
Got it. So I think the workflow would be, though, you would bring the scans not through Edgewise, but directly into LFM, and bring them into PDS via LFM server, most likely, not through Edgewise.
Correct.
Got it. Okay.
Correct.
Excellent. All right. Thank you, John. We've got a couple additional questions that we'll take at the end for John. Kevin, if you could take over take back the screen, or I can make you presenter. There we go.
All right, there we go. Thank you, Chris. And I'll try to hurry because I see we're bumping up against the clock here. John, would you want to give a quick overview of AMEC Paragon? I'll keep
sure.
moving. Sorry.
Sure, I can do that. Actually, our name has been changed to just AMEC. Paragon was a small engineering firm that was purchased by AMEC several years ago, and it used to be called AMEC Paragon. They kept the name for the name recognition, and it has since been we just are AMEC, part of Oil and Gas Americas. Our primary engineering focus is offshore platforms, and we do have a pipeline segment. The company has been around, Paragon itself has been around for, I think, probably 25 years or so. And we're now part of the bigger AMEC.
Okay. Thank you. I just wanted to you to get your background in there and talk a little bit about AMEC. All right. So wanted to wrap this up, give you guys just a little bit of a taste of what's coming within Edgewise here in the near term. Coming in summer, in addition to the PDMS module that John just talked about is available and working now. We're working with the CADWorks team to integrate with CADWorks via their PCF format, which also goes into Plant 3D and several other software applications. So we're really excited about that, to just kind of extend the compatibility of our Edgewise models. With the summer release, we're also going to overhaul a lot of the user interface for Edgewise Plant, and just really clean that up, make it as smooth and nice a tool as possible. We've gotten a ton of user feedback over the last year with a lot of little tips and tricks that we're going to be incorporating. One of the biggies is improving the clipping box and how we do point cloud slicing. It should be vastly improved and should be a really phenomenal tool by the time the summer release comes out. We're also going to be improving the point cloud navigation and make it a lot faster and smoother. We're going to be expanding our spec library to include more features and more specs, and a number of other just fine-tuning details that should really speed up the modeling even more, quite a bit more from what it is right now. For the the software models about 80% of a model automatically, between 60 and 80%. But there's always QA afterwards and other manual modeling afterwards to finalize the model. And so we're going to be improving those tools and making them a lot more efficient as over the next several months. All right, Edgewise structure. We're really excited about this. This is coming out here next month in April, and it's looking fantastic. What the software is doing right now is extracting steel, and does it very, very well. We're getting great recognition rates on the steel. Very automated, and everything is based on specs, and so every component that we create is based on what's in the steel catalogs, and we're building out those catalogs now to include catalogs from a number of different countries. Right now it's AISC, but we're working with some early beta testers to build out those catalogs. We almost have it exporting to Revit. Should have that done in the next day or two. That's looking really cool. And then we'll be working with John to export to PDMS as well. It should be very similar to the PDMS export of pipes. So it should carry all the intelligence and should be a very seamless export from Edgewise, handing off to PDMS and having an intelligent model. We're also going to be making a beta available to existing customers here very shortly. And we're, the feedback we've gotten so far is extremely positive, and we're looking forward to just getting out and getting into the hands of some of our existing customers here shortly. And I believe that's it for me, Chris.
Okay. We have got a ton of questions, and unfortunately we don't have that much time, but what we will do, we have a record of every question asked and who asked it, so we will make a move to answer all of those prior to over the next couple of days. We'll just reach out to you directly, but I've got a couple questions here that I'd like to ask before we break here. For Matthew Bird. What program did you use for the topo in your project, and did that PDMS?
Okay. Yes, depending on which software you wanted to get the topo/ground surface model into, there's multiple ways of doing it. If you want it in AutoCAD format, the Edgewise ground surface model extraction is a very efficient, quick way to get that. Currently, it doesn't come from Edgewise into PDMS at the moment. So if we were going to get we can get a ground surface into PDMS. It just has to be done in a different way. Currently, we use a mixture of AutoCAD, creating a ground surface, and we export that from reality links into a .mac file that can come into PDMS. So there is a way to get it in there, but it's a little bit harder with PDMS than it is just bringing it into AutoCAD.
Okay, and another one for you, and this is a recap. Registration points between scans in a targetless way, in recap. Do you have any best practices? We've tried finding common points on multiple axes versus the same axes, etc., with variable success. So what are your best practices for picking registration points in recap?
Yeah, when you're doing the scan-to-scan, I know it says it doesn't need to be right on top of each other, but yes, picking good clear surfaces. It doesn't want rounded objects usually. A mixture of things worked though. We would use flat surfaces of like electrical boxes and make sure that we're picking those points accurately. It did help things become a little tighter. It didn't usually work too well to do like a concrete pad, something on the ground facing upward. We mostly did the sides of things pointing in different directions. And it did, in recap, if you do pick those points and it comes up and says it's not going to register well, you can just cancel, do it again, and it'll give you different results. Don't just follow through if it says bad. You can definitely find different objects to try to use as your points. And that's where it is still new, and it does have a little bit of issue with that, but it works well.
Okay, great. Question for Kevin Williams. Actually, two questions that are somewhat related. Any plans to bring Edgewise data into SolidWorks, and could you discuss more your integration with Plant 3D?
All right. SolidWorks. We have talked to the guys at SolidWorks just briefly, but that's a little more long-term thing to be able to get into SolidWorks. Plant 3D, the PCF import will actually allow you to create ISOs, but we currently are not able to make the full 3D model, but we can make ISOs out of different lines, and so it's kind of a partial connection there to Plant 3D from Edgewise.
Okay, and Kevin, another one for you. How does ClearEdge handle insulation? Looks like only bare pipes can be modeled out of laser scan. How do you know insulation thick?
Okay.
For Kevin.
So the software is not magic. It doesn't. There's nothing inside of a laser scan to let you know that you're looking at insulated pipe versus exposed pipe. So you do have to have some sort of a knowledge, either by pulling away part of the insulation or by looking at the specs for the plant, the design. But the software Edgewise can, if you know the insulation, which is all you can ever do is know it a priori. If you know that, then you can type that in, the insulation thickness, into the smart sheet inside of Edgewise, and it will handle it appropriately. You can export either as an insulated pipe or as a non-insulated pipe diameter.
All right, great. And so it's 2:05. Let's ask one more question. This one is from Matthew Bird, and it's actually quite an interesting one. So what settings do you use for scanning on the Focus 3D? How long were the individual scans in the dense piping area versus the longer distance perimeter scans? Another way to ask this question is, so what in this project, what are you finding to be the effective range of your Focus 3D? Where, was there data degradation for the long range scans, and so forth? If you could delve a bit into that, that'd be great.
Yeah, for those scanner users out there, there are, on the Focus 3D, you can change your quality setting and your resolution setting, and those do different things. The resolution is going to increase how many points you're picking up and how dense that is, and the quality is going to kind of deal with noise issue. So it's going to sample with the laser multiple times and make it a little bit tighter. Most of our scan setups on this project, because a lot of the pipe and a lot of the steel and everything was up close in those dense areas, we stuck to about a 5-minute scan. Once we started getting a little further out and we had a bigger overview, we would sometimes do 9 minutes. And the range on this scanner, this is the Focus 3D, not the newest one, but it has about up to 120-meter range, and we never like to push our limits. Everything is so close in a project like this, though, that you never have to. So on a project like this, the normal settings would be about a 1/4 resolution or a 1/2 resolution with about a 2 quality setting on the Focus 3D, and that gives about a 5 to a 9-minute scan time.
I can't resist this one last question from Matthew McCarter. Are there any plans for IFC export? This should solve interoperability issues on lots of BIM software for Kevin Williams.
Yes, there are.
We just talked about it the other day.
Yep. So yes, we do plan to export, particularly first the structural components, structural steel, to IFC format. We understand that goes into a lot of different applications, and so the current the beta version of the software will export to AutoCAD, MicroStation, and to Revit. But through IFC, we know we can export to several other different applications as well. So yes, that will be coming soon.
All right, so we're 10 minutes over, guys. Thank you all for joining us. I thought this was a great session. Thank you, Matt and John and Kevin. Our next webinar is on Tuesday, 4/29 at 1 p.m. So same time, Eastern Daylight Time, Tuesday, April 29th. We'll send you some details. It will feature a number of studies of the clear edgewise structure package. Great stuff. So thank you all for joining us, and we'll see you next time. Bye-bye.